Rheonism amphora, Pithas Kintsuki kiln, Ropsten Cipolia, Goerli Prater, and shadow forking in between. The merge upgrade seems to be on an adventurous road trip to reach the proof of stake world. To help a user choose the best client for post-merge node running, Ethereum cat herders bring the special Know Your Client series. Welcome to PEEPanEIP episode 76. I am Pooja Ranjan and am joined by Marius, an Ethereum developer working on Go-Ethereum client along with my fellow Ethereum cat herders. Thank you, Marius, for joining us.
Hello, Pooja. Thank you for having me.
A little bit about the client. Go-Ethereum is one of the three original implementations of the Ethereum protocol. It is written in Go and is fully open source. Official documentation suggests Go-Ethereum supports the transition of Ethereum from proof of work to proof of stake and will be available as an execution layer post-merge. We will get to learn more about Geth or Go-Ethereum client in this episode with Marius, but first, maybe have a brief introduction for our new listeners.
Sure. Thank you. I'm Marius. I've been on PEEPanEIP 2 times already, 2 or 3 times. I don't really know. But I'm working at the Ethereum Foundation for on the Go-Ethereum team since 2 years now. And right now I'm focusing on shipping the merge and getting test cases for all the clients and Hive tests and fuzzing and like lots of different merge related stuff that needs to be done. And today I'm going to talk about our implementation and some interesting things that we encountered along the way.
All right, that's really nice. And I'm sure with a lot of talk, I don't want to come on the way. So without further ado, let's just peep in.
Today we PEEPanEIP. We look at the Go-Ethereum merge implementation. As Pooja already said, Go-Ethereum is one of the original clients of Ethereum. And right now it's run by 80% of the network. This is bad. If you can, you should run a different client because of client diversity. But we're also happy to have you guys run our client, of course. The Go-Ethereum client is written in Golang, and our focus is specifically the Ethereum mainnet. So other clients like Bisu or Nethermind or Aragon, they also focus on other testnets, other chains, private networks, but Go-Ethereum is purely focused on the Ethereum mainnet, and we support some of the other algorithms, some of the other testnets only for Ethereum mainnet testing, basically. And Go-Ethereum is the only original client that is able to go through the merge on mainnet. Nethermind, Bisu, and Aragon are also able to go through the mainnet transition, but they joined later. And the Geth team is part of the Ethereum Foundation. Geth was started when Ethereum was started by Jeffrey Wilkes, and right now Peter Zilagi is the team lead. We have Felix, also, who I think he was the first employee of Jeff, and Martin, who's also doing the security stuff on ETH1, who also joined the Geth team full time. And yeah, so I want to talk a bit about the merge code, where you can find it. Basically, we have the engine API. The engine API is located under eth/catalyst/api.go. It implements all the JSON RPC namespaces. For example, like fork trace updated, new payload, get payload, and exchange transition configuration. So if you're an avid listener of PEEPanEIP, you already know this. But basically, after the merge, you need to run 2 different clients. You need to run the execution layer client, Geth or Aragon, and you need to run a consensus layer client, like Prism or Lighthouse. And the consensus layer client basically tells the execution layer client what to do. And for that, we use the engine API. And so, for example, new payload tells the is the call for the consensus layer to tell the execution layer, hey, this is a new block. Please execute this block and tell me if this block was executed correctly. And yeah, that's as I said, located under the Catalyst package. This is the name Catalyst was historically grown because Guillaume did the first implementation of this and called it Catalyst. And we kind of still have the name for the package. And the consensus engine is located under consensus/beacon/consensus.go. This implements the verification rules. Basically, the header format or the things that we store in the header, in the block header, they change a bit, and we need new verification rules. We need to verify that, so post-merge, there won't be any uncles in the block, for example. And so we need to verify that the uncle hash is always set to the 0 hash. And blocks post-merge will not have the difficulty set. So we will need to verify that the difficulty is always 0 for these headers. And these verification rules are implemented in the consensus engine. And then we have biggest change is in the sync. I think well, it might not be like line-wise the biggest change, but it's complexity-wise, it's definitely the biggest change is for syncing. So for retrieving the old blocks from the blockchain. And this is located under eth/downloader/skeleton.go. And it implements the reverse header sync. So before the merge, when we try to sync, we will just ask, we can basically, we go from the Genesis block and then we import the next block and the next block and the next block, and we go forwards from it until we reach the current head. And if we see some block that has a higher difficulty than what we currently have in our database, then we reorg to this block. But because we don't have the difficulty anymore after the merge, we have to have the reverse header sync. Basically, the consensus layer tells the execution layer, hey, this is the new block, this is the new head that I want to I want to sync to, and then we take this and we try to find the parent of it, and try to find the parent of it, try to find the parent of it, all the way until the Genesis block. So basically, before that we synced from Genesis to the head, and now we sync from the head back to Genesis, or at least we construct the header chain back to Genesis, and then once we constructed the header chain, then we can download all the block bodies which contain all the transactions, and we can also download the state if we are snap syncing, or we can just download the block bodies and the transactions and execute the transactions, and then we get the state at the head. Yes, and all of this is implemented in skeleton.go. Yeah, then I wanted to talk a bit about some of the merge testnet preparations that we still have to do for Sepolia and Goerli. And what we the problem is these testnets, they didn't have a beacon chain. So the beacon chain for Ethereum mainnet has been running for over a year now, and but these the testnets don't have beacon chains. And so we need to set up the beacon chain. We need to deploy the beacon chain contract. We need to think about, do we want to make this testnet permissioned or unpermissioned? And for Goerli we decided to just use the Prater beacon chain as the beacon chain that we used post-merge. And for Ropsten, we decided to created a new one, the Bobsten chain, the Bobsten beacon chain, and this one is unpermissioned, so you can just join it. And for Sepolia, we decided to make it permissioned, so that only the people that we decide in the beginning to give keys to, they become validators. And the idea behind this is basically it's very hard to find companies or people willing to run validators on the testnet for a long time. And this is something that we've seen with Goerli all the time, is companies will say, hey, we would like to do our testing on Goerli, so we would like to run a validator on Goerli, and we will set up a validator for them or give them a key. And then after like half a year, they lose interest. They shut down their node, or that node is not updated, doesn't follow the chain anymore. And now we're stuck with one less validator. And yeah, we want to be able to support these testnets for the users, so that the users can actually do transactions on it. And if there's like a significant portion of validators not validating anymore, then the chain cannot continue, or there's like lots of forks and stuff, and that's just pretty bad. Then after we set up the beacon chain, we need to specify a high TTD. The TTD, oh, I wanted to make a video about that, but I forgot. Basically, the TTD is, we specified the TTD, the terminal total difficulty, which is the cutoff point, after which the merge occurs. So every block in the blockchain in proof of work has a difficulty, and if we sum up all the difficulties of all the blocks, we arrive at the total difficulty of this chain. And if the total difficulty exceeds the terminal total difficulty, then this block is a valid first block or last proof of work block, and so we can build our proof of stake chain on top. For the Bellatrix fork, we need to specify the TTD beforehand, so that the consensus layer clients can look for the TTD. It's a bit weird that it's done this way, but it's grown historically. And so we specify an extremely high TTD that is not able to be reached. And then later on, when we do the scheduling of the actual merge on the testnet, then we overwrite the high TTD with the correct TTD. And why do we do this? Well, we kind of got attacked on Ropsten, but I'm going to talk about that a bit later. So yeah, how's the testnet forking going on? We have, in addition to forking the testnets, we also have the shadow forks. Basically, the idea behind shadow forks is we take a copy of the blockchain and take this copy through the transition and verify that everything works correctly, and then after a couple of weeks we can just throw it away. So and we share the same state with the normal blockchain. And so all the transactions that are valid on the normal blockchain are also valid on our shadow fork. And so we can execute them there. And that makes it really easy to test the merge with realistic mainnet load. And so there's a mainnet shadow fork going on either today or tomorrow, mainnet shadow fork 7. So we have a really nice graphic here from Etherworld, and it has the 4 Goerli shadow forks and 7 mainnet shadow forks on it, and the timeline. And yeah, mainnet shadow fork 7 is happening today at the day of the recording, so 21st or 22nd of June, or might be tomorrow. We don't really know yet. But yeah, so that's still going on in parallel to the normal testnet forking. So for the testnets, we decided not to merge Rinkeby or Coven. Those are testnets that will stay proof of authority. And the Rinkeby will not be supported by Geth anymore, or I think it's already not supported. I'm not sure. But basically, the idea is these testnets, they grew so big that it's like you need to think several hours to get to this to get these testnets, and that's kind of a pain if you want to spin up a node and just see that everything works correctly, or if you want to deploy a smart contract, test something, and don't care about the result. And the thing is, like, people actually use the testnets for basically for their production stuff, and that is not great. So we are not supporting Rinkeby anymore. We already merged Ropsten. Ropsten was a proof of work testnet, and it's now proof of stake. And we will deprecate Ropsten after the merge somehow in the next year, just because I think it's 300 or 400 gigabytes now, which is quite massive. And then the Sepolia testnet, that is coming soon. It's a small proof of work testnet that we started when we had the interop event in Greece. And because it's so new, it has very small state. You can sync it in under an hour, and yeah, merging it is probably does not give us that much new info, but that's okay. We just need to get it out of the way. And afterwards, we're going to merge the Goerli testnet, and we decided to have these schedule like the schedule that we have right now. So we wanted to have one testnet, a big testnet on the merge, on post merge, for a really long time, so that people can set up their validators, verify that the software works correctly, all of this stuff on a testnet that they are already on. So we decided to have the Ropsten merge extremely early, probably from a software perspective a bit too early. But fortunately, we haven't seen any big issues, so it wasn't too early. But yeah, the idea was we're going to make this as early as possible so that people can already test on it. And then Sepolia basically has to get out of the way. We just need to do it at some point. And for Goerli, the idea is we want to fork Goerli with the final versions. Basically, we want to fork Goerli with the versions that we are really confident in that we'll make it to mainnet. And so yeah, that's why we also recently switched the Goerli and Sepolia forks around. Yes, Goerli of course is proof of authority. And I wanted to talk a bit about some client releases that you need to look out for. 10.19 was released last week, and it contains the Ropsten TTD, and it also contains the Grey Glacier fork. Yeah, so if you don't know what Grey Glacier is, and you're running a node, then you should really figure out what it is. Basically, it's a hard fork that will happen next week. So if you don't, like, you need to update your nodes to 10.19 if you're running Geth, or if you're running some of the other clients, you should also update your nodes because otherwise you won't be able to follow the blockchain anymore. This hard fork only pushes the difficulty bomb because we need some more time to do the we don't really need more time to do the merge, but the block times are already getting a bit long, and we don't want to have a degraded user experience throughout the merge, and that's why we are pushing the Grey Glacier fork a bit. And yeah, the 1020 will have the Sepolia TTD. 1021 will probably have the Goerli TTD, and 1022 will probably have the mainnet TTD. Things might change in this timeline, especially Goerli TTD and mainnet TTD might be in the same fork, might be in the same client release, might be in different client releases. We don't know that yet. And of course, if something happens, there might also be a client release in between. And you should really, if you're running Geth, you should really follow at Go_Ethereum on Twitter. This is where we post about client releases and important updates and things that you should just know about. All right, let's talk about issues. Ropsten merge issues. So we did the Ropsten merge, and the merge itself went extremely good for us for Go-Ethereum. We didn't have a single issue where there was one client combination, Geth Lodestar, that had some problems, but it wasn't on the Geth side, it was on Lodestar. And otherwise, like, went extremely well for us. There were some issues beforehand, and we had to do a TTD override. Basically, we specified a TTD that was too low, and someone started mining the chain with a lot of hash rate, and so the TTD occurred. Basically, the merge occurred before we even started the beacon chain, and so this, like, basically, yeah, we couldn't do anything, and so we had to push a TTD override, and we had to override the TTD to a very high value. And then when we were sure, okay, the beacon chain was started now and it's running and it has the Bellatrix fork, and then we specified the correct TTD and basically pushed out another release, and then the merge happened. During the merge, we had a live stream with the guys from ETH Staker, which was pretty funny. During the time, the Geth team met in Prague for ETH Prague, which was a really nice event. And so we took the week beforehand to have some kind of offsite. And so we had the live stream and had the Ropsten merge from there. The problem was the TTD that we chose after the TTD push was pretty high. So because we were afraid of someone starting another miner with lots of hash rate and making the merge earlier, so we set up our own pool and rented some hash power for it. But the machine for the pool was pretty under-provisioned. So it had 2 cores, didn't have a great SSD. And so just creating an empty block or a block with like 2 transactions in it already took over 5 seconds. And so basically when we import a block and we want to create a new block on top, we first create an empty block on top without any transactions and an empty work package, send that to the miner, to the GPU, and tell the GPU, hey, please seal this block. And then in the meantime, we start executing transactions and building a real block. And then we say to the miner, hey, don't use the empty block anymore. Please build on this full block. And if they seal the full block, then we can send the full block to the network. This is done so that we're not wasting any hash rate. What happened now is that in these 5 seconds, like normally creating this full block takes 100, 200 milliseconds. But because we had so many miners, we had so many miners all connecting to this one machine, which was really small. It took a long time to create these new blocks. So the miners kept finding kept correctly sealing the blocks, and so we had a bunch of sibling blocks for the same block height. So we had 5 or 10 competing blocks all mined by us. And so the network kept forking and reorging. Even though we had enough hash rate, we couldn't actually extend the chain in a way because we kept working on these different forks. Yeah, so if you watch the live stream, you can see us. We had a camera there in the room, and you can see us scrambling to fix it, to provision another machine, to try to restart Geth, to have to flush out some of the events from the event queues and stuff like this, just to make it a bit faster. And and I wanted to talk a bit about other testing that we do. As we already talked a lot about the testnets. We talked a lot about the shadow forks. We're also doing fuzzing. So we have an engine API fuzzer that basically sends weird requests to the engine API and verifies that. So we have different fuzzers there. Some verify that the engine doesn't crash, so the different clients don't crash. And we have one that verifies that different machines or different client implementations produce the same output when called on the engine API. And we also have beacon fuzz, which is being updated to Bellatrix. And we have the Hive tests. So Hive is a really nice platform that continuously downloads the new client releases and whenever we push to master in Geth. And it has we have a lot of static test cases there. So we have the state tests, which basically test all the EVM functionality there. I think it's over 20,000 tests or something like this. And we have for the merge, we have state tests for the merge that test the random opcode, so the changes to the EVM. And we have engine API tests that verify that the engine API is implemented correctly and follows the spec. We have sync tests where we set up a bunch of clients and see that they sync correctly. And we have the CL mock tests. The idea there is for the engine API tests, we have we create test cases that mock out the consensus layer, and we'll ask the execution layer, hey, execute this extremely weird block. And if the this invalid block, and if the execution layer says, okay, we executed this block correctly, then something's wrong. And we wanted to have the same for the CL. And it's not so easy to test because the communication is very one-directional between the CL and the EL. The CL will tell the EL to do something. And so it's very easy to mock out the CL, but it's not easy to mock out the EL for testing the CL. So that's exactly what we did. We basically have a CL that is connected to a proxy that is connected to an EL. And this allows us in the proxy to modify the results that we get from the execution layer client to do interesting tests. And then we have two other really cool things. We have Kurtosis, which is a platform we use it as a platform for running like continuous sync tests. Basically every night we're doing a bunch of tests with all different client combinations going through the transition, and then verifying after the transition that everything was working correctly, that we see blocks after the merge. We've seen full blocks after the merge. Transactions are still executed. We're seeing sufficient attestations and sync committee participation and all of this stuff. So that's done in Kurtosis. And then we also have Antithesis, where we basically also do the same thing, but it's done on a deterministic hypervisor. And so this allows, and basically that they're using some breadth first search algorithm to find crashes, and it allows them to, like, this deterministic hypervisor allows them to basically move in the timeline as they please, and execute operations and revert operations, and see if they can make some of the clients crash. And Kurtosis has in the beginning found a lot of bugs, and right now it looks pretty stable there. And Antithesis is now starting up to find a lot of really weird issues, just race conditions and timing issues that we wouldn't have found otherwise. And yeah, then I wanted to talk a bit about some interesting bugs that we encountered along the way. We have one that is still in the client. That's the last one on the slide. For the people listening in, that's TTD override on initialized database, but I'll talk a bit about it later. We had a Bloom bit panic that was interesting. Basically, when you created the block with a long or short Bloom filter, then you could crash Geth. Fortunately, we found this via manual testing. There were some issues with async block production. Basically, we have these two calls prepare payload and get payload. And prepare payload tells the execution layer client, hey, please create a new payload with these parameters, and then get payload gets these parameters. And in the beginning, we did synchronous block production. Basically, when we got the call, please prepare this payload, we would create the payload, and then we would return the call. But that's not great because payload production might take a couple of 100 milliseconds. But as we've seen on this Ropsten thing, it could also take 5 seconds. And so we had to make this async. One really funny bug that we found on the mainnet shadow forks was that the default gas limit in Geth was 8 million. And we're so like like everyone knows that right now the default gas limit is 30 million on mainnet, but this is not enshrined in the code. This is basically just what the miners have set their local machines to this 30 million or the mining pools. But in the code, it was still set to 8 million. So when we did the first mainnet shadow fork, we noticed that the gas limit continually dropped significantly up until 8 million, and now the default in the client is set to 30 million, so that post-merge we will not drop the gas limit significantly because most of the validators will not set the default gas limit to something different. Then there was a TTD flag that was UN64. The problem is on mainnet, the total difficulty exceeds UN64. So we had some overflow there, which was also really funny. We had a bug that was within. So we have this called this API engine API call called exchange transition configuration, which basically it's used to make sure that the consensus layer and the execution layer have the same configuration, the same TTD set. If we push a block override, then the same block hash set. And within this call, we had some error. The error message was, hey, the TTD is different, but I mixed up the which TTD was which, and so I said the beacon TTD is what actually was on the execution layer TTD, and the execution layer TTD is what actually was on the sorry, other way around. But yeah, you get what I mean. So it was the consensus layer had TTD 10, execution layer had TTD 15, and the error was mismatch in TTD configuration, consensus layer 15, execution layer 10. So the other way around, and it made for some really funny bug reports. And then we had a lot of, or not a lot, but like quite some errors and spec deviations that we found through all the testing methods that I talked about earlier. And one issue that is still open is the TTD override on the uninitialized database. Basically, when you start up Geth with a TTD override and you don't have anything in the database, you're starting up for the first time, then the TTD override will not be applied. Same with all the other overrides, by the way. It's not really an issue because on mainnet, you would never start up a client with a TTD override. You would either run with a normal TTD, or if you set the TTD override, you will already have something in your database. But yeah, I have a PR for it. It's not merged yet. Oh, yeah, and then I wanted to talk about some cool upcoming features within Geth and show the Geth client a bit. What you can see here on the right is reverse diffs. For the people listening in, basically there are two graphs, and it's we compare two different versions of Go-Ethereum against each other, and you can see on the top graph, you can see that the head block for the two versions is mostly the same, and on the so they are syncing in the same time. But on the bottom one, you can see that the database size for one node for one version of Geth is roughly 270 gigabytes, while it is 70 gigabytes for the other version. So there's a huge difference, and they both store almost the same thing, but one stores it in 200 gigabytes less than the other one. And this is the great big feature that we're really excited about. It's called reverse diffs. Basically, the idea is we have the try, and right now it's hard for us to know which parts of the try are stale. So we store states for the last 90,000 blocks, and when we move on with the head block, then we can delete some of the stuff that was older. But we don't really know which of the parts we can delete. And so we have some pruning that deletes some of the try nodes, but it will not catch all of the try node, and it's really imperfect. And what you need to do is we have this offline pruning. Basically, you need to shut down Geth. You run the offline pruner that will delete all of the try nodes, all of the unnecessary try nodes, and you will free up a lot of disk space, and then you can start up Geth again. But these unnecessary try nodes, these stale try nodes, they will accumulate over time. And for example, if you go to, you can really see that this is really good. If you go to Etherscan, they have some really nice charts where you can see the size of the blockchain, basically size of the full node, and full node. Okay, they don't have this anymore. That's the archive node. Oh yeah, you can see it. You can see it here. It grows quite a lot, and then they did this offline pruning, and then it drops quite a lot. But the new version that will basically looks like the open Ethereum here. And so this is something that we're really looking forward to, the reverse diffs. Then we're working on an implementation for Verkle trees and Danksharding and light clients. These are the big things coming up in the next couple of hard forks after the merge. Chain pruning, basically history expiry, so that we are not storing all of the data anymore, but we're saying, okay, the first 1 million or 2 million blocks, we don't really care about that, or the first 10 million blocks, we only care about the new data. There are some ways to get this old data, but it's not under the ETH protocol, not under consensus anymore, and so we don't need to store it in the full node. Then we need to do the Shanghai fork, which also has the withdrawals in it. So yeah, except for the reverse diffs, we don't have a lot of Geth specific features that we're working on right now, because there's so much interesting stuff in like for the Ethereum roadmap that we have to work on, and it's also we're just as I said in the beginning, Geth is really focused on Ethereum mainnet, and so a lot of the experimentation and the like hacking and trying out stuff is for Ethereum mainnet is done on Geth, and we as the Geth developers also support this. But this also means that we don't have too much time to work on other features for our client ourselves. Yes, I hope this gave you. Yes, that's everything. I hope that this gave you a really nice kind of a small insight into what we do at Geth and what we did for the merge. And yeah, I hope you run our client, but I also hope that you run other clients because client diversity is very important. Right now, too many people run Geth. We're very honored that so many people put trust us and trust our software. But the other clients also build pretty good software, and so you should try them out. And you can also run two clients and have a proxy in between. There are some projects trying to do this, especially if you're a bigger staking providers. You should run multiple different clients. So in the event of something happening, you can quickly switch to a different client, either by hand or automatically. Yes, that's it. Thank you.
Well, thank you. Thank you so much for this presentation. Some of the facts I learned about Geth were new to me. I didn't know who started it all. So thanks for sharing that information. And there are so many other new features that people may expect. I hope that the way I like it, many other also will like it. I have a couple of questions that we have collected earlier. The first question is from the integration, fuzzing, and testing side. Some of us may know Marius as a guy who breaks testnet with one-of-a-kind fuzzing and testing experiments. I'll be curious to know, what difference did it make in testing the merge?
Yeah, so the fuzzing has been really nice. We found some issues in the early beginning with the engine API fuzzer, especially on Geth and Nethermind. So, for example, Nethermind could produce both Nethermind and Bisu could produce blocks that they could not insert themselves. So they had some mismatch between the block production and the block insertion logic, and this was something that the fuzzer found. One thing that I created was a bad block producer, basically just a node that produces bad blocks. So it produces a correct block and then it modifies it a bit. It, for example, it changes the gas limit to 100 million, and because that's not like how the gas calculations work in Ethereum, this block should be rejected. And you can just take this and run it on the testnets and let it produce bad blocks and verify that these blocks are not imported by anyone. And this bad block producer found a couple of really interesting bugs. For example, one where I think our hash was replaced with our parent hash. And so because some clients had some caching mechanism, they wouldn't verify that our hash, so the block hash was correct. They would first of all look it up in the database, but because the parent was already in the database, we would see, hey, this block was already in the database, so we're going to accept it. even though the block was malformed and the hash was just replaced with the parent hash. And this led to some consensus issues, I think, on mainnet Shadow Fork 3 or 2, something. But it it was really interesting to see that this could actually produce some bad blocks.
That is good to know. There are so many methods were used, even Kurtosis, Antithesis that you talked about. It's really interesting to know that we are trying to make it foolproof. Talking about yeah,
and it's also we're testing so much. We even found some bugs that were dormant in the code bases for a long time. I don't think any Ethereum update has ever been tested this thoroughly, and so it's really good.
Yeah, right. This is one of the biggest upgrade, I'm assuming. So it's good to have it as firm as it can be. You mentioned about shadow forking. We have done like 6th and 7th is today or tomorrow. You mentioned in the presentation. What is the main reason for continued shadow fork, and how many more shadow fork can we expect in future?
So we roughly plan to do one every week. It just gives us a really good confidence in everything. It lets us run through the transition over and over again and see that everything works. And if we see issues or if we see regressions, or if we see some problems on, for example, on Ropsten, we can also test the same thing on the mainnet Shadow Fork and see that that these issues have been fixed. So Shadow Forks have this huge advantage that we're using real transactions, we're using real state. Syncing a node on the Shadow Fork gives us a good indication on how it would be to sync a node on the post-merge chain. So we can also do a lot of benchmarks and just tests to see that everything will work as expected post-merge. And that it's really great that we can do this. And I think it's also might be the only time that it is that easy to do shadow forking, because shadow forking in proof of work is pretty hard, because you need to mock out the ETH hash verification part, and shadow forking in proof of stake is also not that easy because you need to replace the validator set somehow and make sure that you have the correct validator set up to a point where you want to start the shadow fork and then have a different validator set afterwards. So yeah, it's great that we can do it for this update, and we will be able to do it for future updates as well. But it's not as easy for future updates. And for the merge, it's basically it's gift. It's we don't have to change the software at all.
That is nice. I mean, with so many things going on, if we can automate something or simplify something, good for the developers, right? One other thing, matrices. I have seen that during the Altair upgrade, the beacon chain upgrade, they were talking about a lot of matrices. We had a chat with Paritosh and Leonardo on beacon chain matrices. I'm assuming that there are matrices being taken care here in the merge upgrade as well. Are there any EL specific matrices that either the Geth team or all the execution layer client team are keeping track of?
Yeah, so I think the biggest one that we always take track is the execution layer head. So that is just the head block that we currently have in our canonical chain. That one is the most important metric that we have. It basically tells us, are we in sync or are we not in sync? So again, during the Ropsten merge, we showed our we had this really nice dashboard which had like a lot of different metrics that we collect from the consensus and the execution layer, and it also showed all the different heads of the different nodes, and you could see, hey, this node dropped off, and so the head is not advancing. We also have metrics. We have a lot of metrics for the download, like the download, the synchronization part, and for the execution part, and that's also very, like, it's very interesting and important to also look at these, and on some of the mainnet shadow forks we took a look at them, and just to make sure that block processing doesn't magically become extremely difficult from now on, and that everything is basically the same as it was right now. We have like huge amount of different metrics that we track internally for developing and for updating our code, but it's not really important to the users. But if you take a look at the Ropsten the Ropsten merge call from ETHstaker, then you can see our dashboard, and I think it's open source. It should be, if and you can either you can put your own clients into it and basically see how they behave during the transition.
It is nice to know. I mean, matrices are the keys to performance evaluation, and when we are doing so much of testing, evaluating them in a right way is also very helpful. I have one question related to the testnet, the public testnet. You did mention about creating beacon chains for Ropsten, for Sepolia and all, but the Goerli and Prater, I think this merge is going to be a prudent one, because they, unlike RBC and SBC, like Sepolia beacon chain and Ropsten beacon chain, Prater is a living testnet for beacon chain for quite some time, and so is Goerli. So is there any special preparation done for Goerli and Prater testnet merge?
So for the Goerli part, no. I think Paritosh, you would have to ask Paritosh about that. He knows more about the Prater than I do, but I think they looked at how many validators are run by us, so the core devs, the different client teams, and how many validators are run by the community, how easy it is to create new validators, to add new validators to it, because what we really don't want to have is someone just taking millions of Goerli ETH, starting 50% of new validators, and then just shutting them down and leaving us with a non-finalizing testnet, Goerli testnet for a couple of weeks. It's a good test, but we're doing these kind of tests. We're doing on the shadow forks, and so we really don't need to do this on a testnet that users are actually using and that companies depend on, and so we'd like to have the testnets run pretty smoothly so that people can actually test the stuff there.
All right. I mean, undoubtedly, Marius and Paritosh, along with all other devs involved in testing the merge, are heroes of Ethereum community. For our listeners, we have recorded an in-depth conversation with Marius and Paritosh on Goerli testnet and shadow forking. So if you have missed watching it earlier, check out episode 63 on PEEPanEIP. Marius, I have a couple of more questions. We can probably go over them quickly.
I'm happy to answer.
That's awesome. So I'm wondering about the client combination. You mentioned earlier, like there would be now a validator has to go with both EL and CL client, what do you think would be the best client combination for Geth? Or is there something called as the best client combination, or you think it is going to be similar with any of the EL?
So we're testing anything. We're testing all the client combinations, all 25 of them, or 20 of them. No. So it's with basically we kind of stopped testing Ethereum JS as an execution layer because they cannot really participate in the mainnet shadow forks and the Goerli shadow forks because these chains have just too much state and too much history for the JavaScript implementation to handle. So we have right now we have 4 execution layer implementations and 5 consensus layer implementations. But we're testing all of the different combinations, and all of the different combinations work fine. So I don't see a problem. You can just basically just pick something at random and run with it. And despite some smaller issues that we're still figuring out, it should work fine. And I'm from the Geth team, and I would, of course, I'm running Geth and different client combinations, but I think all the other clients, they are tested in a similar fashion to us. I make sure to create our test cases in a way that they can also be used by others, and have these Hive tests and the fuzzing and everything, and make sure that every other execution layer client can participate in it, so that they have a similar level of testing, a similar level of readiness. And yeah, I have a consensus layer client that I prefer just because I really like the team behind it. But I think all of the consensus layer clients are great, and you just pick one.
Awesome. So yeah, just pick one. While we are talking about client diversity here, EL clients will not be the decision maker for a new block inclusion after the merge. So in your opinion, will it change the chart of client diversity, or do you think Geth will be the majority client even after the post-merge?
I think Geth will be the majority client post-merge, just because so many people are used to running Geth. I hope that other clients will have a greater share than they have right now, especially with Open Ethereum not going through the merge. I hope that Aragon will probably take a lot of the client share of Open Ethereum. That would be really nice. I hope that the people that run Open Ethereum will not switch to Geth, so that we will have a bigger share. That would be bad for client diversity. And I hope all of this testing, all of these efforts that we do, will encourage some of the people to switch to minority clients. And as I said, for bigger staking pools and bigger staking operations, it's just negligent to not run all of the clients and have them at least synced, so that in the case of something happening, you can quickly switch your validators to a different client combination, and you can run all 25 minus all the combinations with so all 20 combinations without, so you can run nodes without having to stake, and so the staking pools should run all 20 client combinations and then point their validators to one, and in the case of something happening, they can then point their validators to another one, and it's not that hard to run all 20 client combinations.
Yeah, I hope so. This client diversity thing, I have seen that in the CL side. It is getting a good picture now. I hope something works for the EL clients as well, and it gets a good picture. Even if Geth is a major client shareholder, the difference between Geth and the second client should not be that big. All right. My one question about the personal experience as a developer, how would you describe your journey towards the merge upgrade so far? I know there are so many stories and you have shared some of them. Any favorite?
Yeah, it was really like I when I joined in 2020 at the beginning of the pandemic, I joined halftime because I wanted to finish my master thesis. Not halftime; it's part time, 75%. And I wanted to finish my master thesis, and I started working on stuff. And there was some like Guillaume basically did the heavy lifting on the engine API implementation and all of this stuff, and Peter did the heavy lifting on the sync, and Gary also did some really good work on the merge stuff. And basically, it already went on in the first year that I was part of the foundation, but it wasn't too much. And then we had this event in Greece, and 2 weeks before the event, I was like, "Hey guys, these people in Greece, they expect us to have like a working implementation so that we can like start a testnet there and do this interop op stuff." And yeah, no one no one really cared. So I was like, okay, we have 2 weeks. I'm just going to take it over. Is that fine for you guys? And I updated our implementation to the newest spec, and this gave us a really good head start. So basically, our implementation was mostly working on the first day, and so we could work with the other CLs to make the interoperability working pretty well. And yeah, Greece was just an incredible event. It was where I met most of the people for the first time, and it was just incredible seeing these really smart people in a room together, focusing on this one thing, trying to push it. And it was also like it was a really nice hotel, and we stayed. It was sunny, and it had a beach, and we stayed in the basement of the hotel for for the whole day, hunched over our computers, 40 people in a room, no windows, nothing. And after the third day, I was like, okay, between after lunch, I'm going to take 1 hour to go to the beach to chill a bit before going back to working. So yeah, that was incredibly great, this event, and it's I think it cut down the time to the merge by at least 6 months. And afterwards, we had a lot of these shadow forks and testnets and stuff going on, and that was also incredibly nice. Yeah, it's been a really good journey, but I also hope it comes to an end soon. I also feel like I'm working a bit too much, because it's like the merge is also kind of like a passion project for me. I think if we can do the same thing that we do right now, but by using less energy, that is really incredible. And if right now Ethereum produces roughly 20,000 tons of CO2 every single day, and I have the feeling if I with my own work can make this can even influence the merge by one day, I I've basically have the CO2 budget for my whole life saved, and that is just an incredible feeling. And yeah, it's been a really nice journey, but I hope to have some some off time soon after the merge, so I can also chill out a bit.
Nice. That's quite nice thought of decreasing the CO2 of the environment, plus all the hard work. We really appreciate that. I have heard similar stories about having in-person meeting for testing, and definitely it reduced the work, the timeline that otherwise it would have been. Well, thank you so much for all your time. It's time for wrap up. Anything else that you would like to share with our listeners in terms of supporting Ethereum clients or supporting the upgrade in general?
Yeah, if you're running a validator, you need to update your nodes for the gray glacier fork that is happening next week, depending on when this episode comes out. But if you're running a node, update your nodes. If you're running a validator and you want to learn how all of this stuff works, then go to Ropsten, deposit some Ropsten ETH there, start up your validator and test it. You can test it already on Ropsten, and it's super easy. It's basically the same thing as you already did on mainnet if you're running a validator. And if you are a service provider at any sorts, go test your software on Ropsten. There shouldn't be too much changes. So there's only one small change within the EVM, and that is that the difficulty opcode now becomes the random opcode. So it takes the beacon randomness, the random randomness from the beacon chain, and exposes it to the EVM. And that's pretty cool change. But if your protocol depends on the difficulty opcode, then you should make sure that your smart contracts work after the merge. And also all of your backend stuff, all of your Web3.js, whatever you use, that should be tested on Ropsten so that everything works after the merge. Yeah, that's what I want to tell the community.
Sweet, thank you so much, Marius. We really appreciate you sharing insight on client development and merge preparation. Thank you so much for your time.
Thank you for having me.
Go-Ethereum is the leader with the 80% share on the execution layer client demographic. Certainly provide confidence to an Ethereum node runner, but this also increases pressure on client developers to maintain the client. Generally, they are underappreciated. My wish is with this talk, users may learn about Geth client as an execution client, run a node, participate in the network, and also be appreciative of the hard work that is being put in by the team. And on this note, thank you everyone for watching and listening to this special episode on Merge. Should you have any question, leave a comment or reach us at ETHCatHerders Discord. Check out description for links to useful resources and guest Twitter. Stay tuned for more on Know Your Client series. Keep sharing your love with Ethereum Cat Herders. We'll be back soon.